Good morning, students. Welcome back. I hope you have started understanding the concepts of physics. For better clarity, please keep on reviewing your topic from the videos which I have sent earlier. Keep on revising them, playing them again and again. Other than that, read the text from your textbook as well. That will help you a lot. Okay. So last time we had started with graphs and I had introduced distance time graph. So we had done three types of distance time graph. The first case was for drawing a graph, we always take time on the x-axis and we take distance on the y-axis. Okay, here we were taking distance and here we were taking time. Time is taken on x-axis because it is independent variable and distance is taken on y-axis because that is a dependent variable. That means value of distance depends on time. It changes with the time. That is why. So our case 1 was for object in state of rest. Object at rest. So for that, distance time graph was a straight line parallel to time axis, right? Distance time graph was a straight line which was parallel to time axis. Second case, second case was again we will take time on x-axis and distance will be taken on y-axis, right? Second was the case for uniform motion. In case of uniform motion, we had seen that distance time graph was a straight line, right? It was a straight line passing through origin. So this showed that an object covered equal distances in equal interval of time. That is why distance time graph for uniform motion is always a straight line. Okay. Third case was the case for that was the case for non-uniform motion. So for non-uniform motion, again we take time on x-axis and distance is taken on y-axis, right? Here we take distance and here we take time. So for non-uniform motion, the graph was not a straight line, it was a curved line, and that can be curved in any shape. All these are cases of non-uniform motion. That is, object is covering unequal distances in equal interval of time. Then I told you one more thing, that slope of distance time graph always gives you value of velocity. Today we are going to discuss velocity time graph. Okay, so velocity time graph, first case they have discussed here is case of uniform acceleration and second is of uniform retardation. Before that, there is one more case as per your book, that is the case of uniform velocity. So case 1 as per your book, that is the case of uniform velocity. Suppose we are taking here different time intervals and speeds corresponding to them. Suppose I am taking time at different time intervals. Let us say in hours, if I am taking time, I take it at 0, 1, 2, 3 and 4 hours. Here a time I am taking in hours and velocity I am taking in kilometer per hour. At 0 time the velocity was 40 km per hour. At 1 hour it was again 40, 2 hour again 40, 3 hour again 40, 4 hour again 40. We see that the velocity of the object is not changing with the time. Neither it is increasing nor it is decreasing. If we plot this on a graph, here we have taken time on x-axis, that is in hours, and velocity in kilometer per hour on y-axis. If we take it 0, 1, 2, 3, corresponding here velocity as 20 and 40. Corresponding to time 0, the velocity was 40. Corresponding to 1 hour, again 40. Corresponding to 2, again 40. So we are saying that the velocity is not changing with the time. Velocity is always uniform. So if you join all these points by a free hand, it comes out to be a straight line parallel to time axis. So this is the case of uniform velocity. That is, the velocity of the object is uniform or it is constant, it is not changing with the time, then velocity time graph will be a straight line parallel to time axis. Rather than uniform, we should rather use the term constant velocity, or we should say it is the case of uniform motion. So it would be better to write here if we write constant velocity, because the velocity is not changing with the time. With uniform, there can be confusion that there can be uniform increase or decrease. Then there is one more point given in your book, that what is area given by graph gives. If you take 2 points A and B on the graph, from A I draw a perpendicular, let this point be C. Corresponding to point C, let time be t1. Corresponding to point B, this is point D and the time it denotes be t2. Okay, so we have taken 2 points A and B on this line and we have drawn perpendicular. A के corresponding you get point C and time it talks about is t1. B के corresponding you get point D and it corresponds to time t2. Now can you tell me that what is this area under the graph? We know that this is a rectangle. Here ABCD is a rectangle, and what will be the area? That will be length into breadth, so I can write it as AC into CD, right? But what is AC here? This AC is 40, so I can write 40 in place of AC into, next I have to tell what is CD. What is CD here? Can you tell me that? Very easy. See, this distance is T1, because we always take, whether we are taking speed or time, we always take it from the origin, the starting point, that is O. Now at point D the time was T2, so this complete time will be T2. Then what will be CD here? CD will be naturally the difference of 2, that is CD will be T2 minus T1. So in place of CD we write T2 minus T1. Can you tell me what does this quantity give? This is speed into time. From the formula, speed was distance by time. So what will be speed into time? That will be distance. Or you can also write displacement, because we are talking about velocity time graph, so it is better to write displacement here. Otherwise distance is also correct. So that means area under the graph, this complete area, what does this give? This complete area under the graph gives the distance traveled. Like in case of distance time graph, we had done that the slope gives you value of speed. Similarly in velocity time graph, area under the graph gives you value of the distance. Let's see how we did this. For this we have taken this complete rectangle ABCD. Okay, from A I had drawn perpendicular to C such that the time here is T1 and at point D the time is T2. Now what will be this complete area? This is a rectangle, so it will be length into breadth given by AC into CD. But what is AC? That is 40, because the speed is constant. Then what is CD? This is T1 up to point C. Up to point D the length is T2. Then what does CD become? CD will naturally will be the difference T2 minus T1. So 40 into T2 minus T1, that is speed into time. According to formula, speed was distance divided by time. Speed was distance divided by time. Then what will be speed into time? Speed into time will naturally be equal to distance. So that is what I said, that area under the velocity time graph gives you value of distance. This was the case of constant velocity. Even if you take case of acceleration or retardation, in both the cases area under the graph always gives you value of the displacement. If we are talking about a velocity time graph, area under the graph gives displacement, and if we talk about distance time graph, area under the graph gives you value of distance covered. The second graph which they have taken is the case of uniform acceleration. In case 2, if we say that time and corresponding velocity, if time I have taken as 1, 2, 3 and 4 hours so on, corresponding velocity is 5, 10, 15 and 20. Let this be in kilometer per hour. If we plot these points on a graph, taking time on x-axis and velocity on y-axis, here we have taken time and here is our velocity. 0, 1, 2, 3, corresponding velocity is 5, 10 and 15. So starting we are taking 0, 0, that is when time was 0, velocity was 0 naturally because object was at rest. When time was 1, velocity was 5, time was 2, velocity was 10. When time was 3, the velocity was 15. If you take all these points and join them by a free hand, it comes out to be a straight line. That is the case of, can you tell me what? Can you see from the figure here, from the data given here, that time is increasing at equal interval and velocity is also increasing by equal interval. So this is the case of uniform acceleration. Yes, we had done when velocity changes or increases by equal amount in equal interval of time. That is the case of uniform acceleration. Correct. So like in case of uniform motion, distance time graph is a straight line. In case of velocity time graph, uniform acceleration always gives you a straight line graph. So can you guess now what will be the type of graph if we take non-uniform acceleration? Naturally in that case, graph will be a curved line. This is time, this is velocity graph. Here the slope is going up, but it is not a straight line graph. This is the case of non-uniform acceleration. Can you tell me what is the difference between this graph and the second one? Both are non-uniform because they are not straight, but in the case of first graph the slope was going up, so that is the case of acceleration. But in the case of second graph, the velocity is decreasing with the time, right? Because as the time is increasing, you can see that the velocity is decreasing. So this is the case of retardation. So if in velocity time graph you get a straight line which is parallel to time axis, that is the case of constant velocity. If you get a straight line path, straight line graph, that is the case of uniform acceleration. If it is a curved line, it is non-uniform acceleration, and if the slope is downwards, that gives you value of retardation. Okay, as I told you that in case of velocity time graph, area under the graph gives you value of the distance covered or displacement that we had discussed in case of constant velocity. I am taking the second graph, the same one as shown in your book on page 106. This is the case of an object which is undergoing uniform acceleration. So for that they have taken velocity time graph. Okay, time and velocity on this axis. They say that it is a straight line. It is a straight line showing that this is the case of uniform acceleration because the velocity is increasing by equal amount in equal interval. If we take 2 points A and E, I am taking the same naming. I am taking the same naming as given in your book. This is point A and this is point E. From A, I draw perpendicular here like this, such that this is point B. From E again I draw a perpendicular such that this is point C. Now if we talk in this graph about the area covered, whenever we talk about the area covered, we have to take the area between the given line, this line which we have drawn. Okay, let me show you this. So I am talking like if this was the line which we had drawn, if we are taking the area covered, that we have to take between the given graph, means the line which we have drawn, like in this case OE is the line which we have drawn. OE is the line which we have drawn, so we have to take area between OE and the time axis. Here I am taking 2 points A and E and I have drawn perpendicular from them. So I have to take area between point A and E. Which area I am talking about? Between point A and E and this time axis. I am talking about this area. We are saying that area under the graph gives you value of the displacement. So how will you calculate the area here? Very easy. As you can see that this is a trapezium. ABCDE is a trapezium. Also we can say that this is the sum of a rectangle and a triangle. Okay, so corresponding to point A, here I have taken time t1 and here it is time t2. So here area, that is ABCDE, is equal to displacement, that is equal to area of a rectangle ABCD plus area of triangle ADE. We know that this figure is composed of a rectangle and a triangle. Area of rectangle is always length into breadth, AB into BC. Area of triangle is half base into height. Correct. Here the base of the triangle is AD and height is ED. If we talk about rectangle, this is the length and this is the breadth. So this complete area will be equal to displacement. These relations, that which quantity is given by area of the graph and which quantity is given by slope of the graph, these we will be using when we will be deriving equations of motion. Okay, so let's revise once again what we have done. In distance time graph, the slope of distance time graph always gives you value of speed. Similarly, in case of velocity time graph, what will the slope of velocity time graph give? That will give you value of acceleration, right? How? We had said that slope AE, as in distance time graph, if we have this triangle, I'm talking about this particular triangle, the slope AE is always given by ED divided by AD. Okay, if corresponding to point A, we take the velocity here as v1. Corresponding to point E, we take velocity as v2. Can you tell me what will be ED? It will be naturally v2 minus v1. And what is AD? AD will be t2 minus t1. What is change in velocity by change in time? That is rate of change of velocity and is equal to acceleration. Proofs as such for this will not be asked. I'm just telling you that how these relations are derived. You just have to remember the key points. What are those? First, slope of distance time can be written as ST. Graph gives value of speed. Second, slope of VT graph, that is velocity time graph, gives value of acceleration. And third, area under velocity time graph gives value of displacement. This is very important to remember, can be asked in 1 mark question as well. All the graphs are very important. Sometimes you are given graph in the paper and you have to interpret the type of motion. So see, graphs are very important. Just by looking at the graph we can tell that what type of motion that object is executing. At the same time, from the slopes we can calculate the speed or the acceleration, and even we can calculate the displacement from the area. How to calculate velocity or acceleration from slope, or how to calculate the displacement from the area, that will be more clear when we will be doing numericals based on these topics. Okay, so your work for today is you have to revise the entire chapter up to the topic which we have done, because I want all the basics to be very much clear before I start the next topic, which is most important topic of this chapter, that is graphical equation of motion. We will be doing 3 equations and we will be deriving them from graph. So graph should be very much clear by next Monday, everyone. If you have any doubt, you can always call me and please ask. Okay, very important that your concept should be clear. Okay, so that's all for today. Thank you so much. Bye bye.